Hello everyone, we are Team We Code ZSH presenting a project AIS, Autoimmunity for Systems, a real-time threat detection and adaptive cybersecurity platform. Our team members. Each of us contributed to different aspects from data collection, RAG development, reinforcement learning, backend integration to deployment and dashboard design. Problem statement. Traditional security systems rely on static rules. They slowly react to new attacks and can't learn from past threats. The result, delayed response, poor correlation of alerts, and vulnerability to evolving cyber attacks. Solution. Our solution is an AI-powered adaptive defense system with 4 layers. Context-aware threat analysis using RAG and LLMs, intelligent decision-making with a deep reinforcement learning agent, automated response execution that acts instantly on threats, continuous self-learning loop to evolve defense strategies over time. Tech stack. We used Python, Linux, and Docker for environment. AI components include Microsoft 5.2 Mini, Llama 3.1, and Gamma models integrated with stable baseline 3 PPO for reinforcement learning. Datasets like UNSW NIB15 and CIC IDS 2017 were used for training and validation. We are initializing the Docker Compose along with the main script threat analyzer. Now when I open my localhost website, which is a simple login and sign up form, now let us register ourselves with a name and password. When we move back to our script terminal, we can see the log of the entry has been recorded. Now let us log in with the same credential. We can see in the terminal, the threat is low. Now let us try SQL injection code with random password. Now when we go back to the terminal, we can see the threat has been detected as an SQL injection. Its risk as critical, so the reinforcement learning agent has isolated the entry of the database, which shows the database error in the login form. Running successfully on secure and powerful IBM Linux 1 platform. At its core, the script uses a large learning module from Hugging Face to intelligently classify complex threats like SQL injection and DDoS attack. For guaranteed uptime, it includes a seamless fallback to reliable rule-based system. Now it automatically generates this professional dashboard. We can see instantly the threat distribution, a clear breakdown of risk level from critical to low, and a focused view of top 10 malicious IP addresses responsible for attacks. Most importantly, it produces a prioritized step-by-step remediation plan for each critical incident. It provides an immediate action like blocking an IP, along with short-term fixes and long-term security strategies. Here we open a dashboard which is initialized by Streamlit. We have options such as JSON, JSON, and CSV. For now, let us see JSON file. Let's select our output JSON file which has been processed by the LLM. We can see the visualizations of different types of threats. We can see the risk level distribution, top threats vectors such as DDoS, brute force, and normal and SQL injection. We can also see attacks versus normal traffic which come from the website. We can also see visualization for different IPs. At the end, we can see formatted logs, which is easier to understand even for a non-technical person. Critical attacks are in high in orange, and normal in black. We can also see the filter option towards the left, where we can filter all entries for no filter, attack only for attack logs, and normal only for normal logs. The wow factor. Our self-learning adaptive brain combines RAG and reinforcement learning to turn unstructured chaos into intelligent, explainable, and predictive defense, a step beyond static cybersecurity systems. Learnings during the datathon. During this journey, we learned to deploy scalable AI models on IBM Linux 1, use quantized LLMs for efficiency, and design custom reinforcement learning environments with meaningful reward functions. Thank you.